All right, guys, here is the last set, nth roots with variables. Over here, I have 3 times the cubed root of 125x to the power of 4. Same steps. Let's go ahead and factor this number on the inside. I know that 125 can be broken down into 25 and 5. I can't break down 5 anymore, but let's break down 25 into 5 and 5. All right, so here are my 3 factors. I can't break them up anymore, so let's rewrite our expression. I have this 3 on the outside, and then the cube root of 5 times 5 times 5. And then I still have this term over here, x to the power of 4, so I need to write that out 4 times x times x times x times x. And then once it's all factored out, I need to go ahead and look for groups of n. In this case, my n is 3. Here's a group of 3 5s. Here's a group of 3 x's. And this one is just left alone. It's just individual by itself, so leave that one alone. After I find my groups, go ahead and pull out one of each group, separated by multiplication. So here's 3 from the outside. I need to multiply that with 5, and then multiply that with x. And then the cube root with the x left alone on the inside. All right, let's simplify the outside by multiplying. So 3 times 5 gives me 15, and then I still have this x. And then the cube root of x. This is my final answer. All right, next one, part B. I have the cube root of negative 64h to the power of 6. Let's break down this negative 64 using the factor tree. I can divide this by 2, but I can see that I can also divide it by 4, so let's do that instead. So negative 4 times 16 would give me negative 64. And see how you already have a 4 here? I can see that this can be broken down into 4s as well. So 16 can be broken down into negative 4 and negative 4. And this is a good pattern for you to see. I'm looking for groups of 3. I know I can break down 4 into 2s, but I can stop here because I already see a group of 3. So my next step, let's go ahead and rewrite the expression. I have the cube root of negative 4 times negative 4 times negative 4. Don't forget about your variables. Times h times h times h. Let me write it down here. Times h times h times h. 1, 2, 3, 4, 5, 6. All right, next up, look for groups of 3. So here's a group of 3. I have negative 4s. Here's another group of 3 h's and another group of 3 h's. Once you find those groups, let's pull out one from each group. So on the outside, I have negative 4. Here's an h from that group, and then here's another h from this group. All right, and I have cube root on the inside. You guys notice how there's nothing left inside? We already grouped them all up. That means that there's nothing left. So actually I don't even need this cube root anymore because it all simplifies down. So over here, I'm left with, let's just go ahead and multiply this all out. Negative 4 times h gives me negative 4h to the power of 2. All right, last one. We have 4m with the 4th root of m to the power of 7. There's no number on the inside, so I don't need to use my factor tree. I'm just going to go ahead and rewrite it with this term expanded. So I have 4m with the 4th root of m 7 times. So m times m times m. I'm going to write it down over here. Times m times m times m times m. 1, 2, 3, 4, 5, 6, 7. Okay. I'm going to go ahead and look for groups of 4 because that's my root. So let's go ahead and circle groups of 4. Here's a group of 4 right here. 4 m's. 1, 2, 3, 4. I can't circle this just because there's only 3 of them. I need 4 of them to circle. Okay. So once I have my group, let's go ahead and pull that out. I still have this 4 up here and this m. I need to multiply that with an m that I pull out from this group. And then here's a 4 as my root, and then I have m times m times m. Sorry, running out of space. All right, and then my very last step, let's simplify the inside and the outside. So 4 times m gives me 4m squared with the fourth root of m times m times m to the power of 3. All right, and that is simplifying radicals.